this is a tricky one, so I'm going to grab an extra piece of paper here. And similar to other problems we've done, in this case we want to know where do the two functions cross, and where they cross will be at a point, and that point, if it exists, the point would have an x and a y coordinate, and we want to know exactly what is the x coordinate. So I'm going to take log base 10 of x plus 3 plus log base 10 of x minus 5, and I'm going to set it equal to log base 10 of 3x minus 1. And then the next thing we're going to do is we're going to condense this. Now, how do I know that this is not condensed? I see addition or subtraction here that's separating the same log bases. When I condense them, addition turns into multiplying. So I have x plus 3 times x minus 5 equals log base 10 of 3x minus 1. Because I have the same log base, and there's nothing additional, so it's not like a plus 2 or a minus 7 behind these, I'm able to cancel out log base 10, and now I'm going to just solve for x. So I'm going to start by foiling front, outside, inside, and last, and I'm going to move everything over to the same side. And I want to reiterate this again, that for this particular test, it is so important that you show all of your work. It's so important that you show all of your work. And so I have right now, I'm going to add 1 and add 1. Okay, so I have nothing left on the right-hand side. On the left-hand side, when I combine like terms, I have a negative 2, negative 2 and negative 3 is negative 5, and then a minus 14. Okay, let's go ahead and see if I can solve. Remember when we solve and we have quadratics, we could use completing the square method. It's probably going to be a little bit longer. We could always use the quadratic formula, and sometimes we can do factoring. And when we can factor, for most of us, that's the quickest way. So 1 times negative 14 is negative 14. I'm looking for two numbers that multiply to get us negative 14 and combine to get us negative 5. Negative 7 and positive 2. Multiply and combine. So x minus 7 and x plus 2, and I'm setting it equal to 0. Each one of those factors, and I want to say this again, this test requires you to show every single step. So it's so easy for many of us to be like, well, the answer is x equals 7 and the answer is x equals negative 2. It requires you to show every single step. Now next is we have to check for extraneous solutions. That means we've done all the math right, but it doesn't mean that these are the answers. So we're going to come back to this original problem, which is right down here, and I'm going to start with the 7. I'm going to check it. I know that the base and the answer behind it always have to be positive. So let's check. 7 plus 3, it's positive. 7 minus 5, it's positive. 3 times 7 is 21 minus 1, it's positive. 7 is an answer. Now I'm going to check negative 2. Now just because it's negative doesn't mean that we eliminate it. Let's try negative 2. So negative 2 plus 3, it's positive, but negative 2 minus 5 is negative 7. It's not a positive value. It means the only answer I have is 7. Correct answer is D.